So hello guys, this is Paramvir Singh and my talk is based on this topic, network optimization. So we'll be talking about optimizing network requests for two major reasons. One is slow connections and offline state to make our app usable, as well as to make our UI best, user interaction best for slow connections and offline states. In countries like India, we have moved on to 4G, but still in most of the areas 2G and 3G is prevalent. So we have to take care of those situations also. Second reason is reducing battery consumption by the app. Prashni has also talked about many important things about reducing battery consumptions. We will be focusing on this point also. Uh, we will be mainly focusing on how we can optimize our network request for reducing battery consumption. So let's first continue this battery drainage topic. Uh, the main thing is that cell radio hardware is the biggest culprit of battery drain. Yes, your network radio hardware, the small radio, which is used by the applications or by the system to connect to the network, that is the main culprit of battery drainage besides your screen, obviously. That means when the radio is not active, we are not consuming too much battery. So less radio active time means less battery consumption. And the interesting point is that the network radio is not always active. It goes from one stage to another and from another to another one during its life cycle, and that depends on whether we are making active network requests or not. You can see from this figure, uh, at the extreme left there is this stage radio and at standby. This means the radio is at standby mode and it is not, or you can say it is in sleep mode, and it is not consuming battery. And for example, let's say a network request is made by any app in the system. So this radio is now, this radio has to now go into the active mode, which is here, radio full power mode. And in this mode, the radio is consuming full battery. It from going to go from here to here, it takes around 2 seconds. This is called network latency, network radio latency. And when your network requests are completed here, it will try to go on to the low power mode, and it will take 5 seconds. What is this low power mode? When there is no active network request, this radio tends to be in half idle state in order to wait for more incoming network request. If there is no incoming network request for next 12 seconds, it will go into fully sleep mode, where it will not consuming any battery. Now, what is the use of this life cycle? How we can use this life cycle to make our network request more optimized? See, this radio takes around 5 seconds from going into full power to low power mode, and then further 12 seconds from going into low power to fully sleep mode. If we are making too much request, for example, this is our timeline. Just a moment. For example, if this is our timeline, and if we are making too many requests frequently, our radio will always be in the network active stage, and we will not give it any chance to be in the standby mode. So that means our radio is continuously consuming battery. But if we are making larger network request, but at after longer periods, that means we will give more time to our network radio to be in sleep mode, and thus reducing the battery, right? So there is a term designed for this, that is called batching of multiple requests into one. You can see this horizontal row represents the timeline, and in the above example, we are making frequent requests for our network, and after every request, the radio waits to go into sleep mode, and so thereby we are giving less time for the radio to go on sleep mode. But if we batch all the requests for the future, like after 5 minutes or after 10 minutes, if it is possible at all, that means here at this point, at this period, we are giving full time for the network radio to be in sleep mode, and thus reducing the battery. So batching multiple network requests is very important for optimizing your network usage. Second thing is prefetching data. Similarly, just like batching request, we can predict, if possible, we can predict our network usage, our network request for next 5 minutes. For example, you are working on a news app, and you know that sooner or later your user is going to go into the detail of 10 top news articles. So instead of fetching your news articles one by one whenever the user goes into those articles, corresponding articles, you can prefetch all the network, you can prefetch all the articles at one single request, and thus again giving the network radio time to go into sleep mode, thus reducing the battery. So prefetching network request is also very good strategy of uh, consuming low battery power. Next thing is using push instead of poll. Most of the developers already know about this strategy. We have to push, most of the time we have to prefer pushing the data to the client instead of polling the data. Just taking the example of a newspaper app again. For example, you have to, in newspaper app, you have to show the latest updates and headlines to the user whenever the user will open the app. Now, one strategy is to repeatedly ask the server for your news articles. For example, I'm creating a timeline here, and you are willing to update your news articles database in your app, so that whenever the user will open the app, you show the latest updates, right? One strategy is to poll the data after every 5 seconds. Poll the server for data after every 5 seconds, or after, this can be variable, this period, it can be 10 seconds, or it can be 1 minute, or it can be 2 minutes, right? In any case, this multiple pollings, continuous polling, is going to consume too much battery. We should refrain from this. Instead of this, we should use push. What is push? In push, your server is going to push the data to your client, to your app. So whenever there is a new news article at your server, or any important update at your server, which your app may require, instead of your app asking the server again and again for the data, your server will push the data, and thus your app would not have to do polling, reducing the battery to the maximum level. Right. So for pushing, you can use Google Cloud Messaging, push notifications, and now there is Firebase Cloud Messaging. We can discuss about that in our next video. But main thing is that you have to push instead of poll. Now for slow connections, we were earlier talking about slow connections like 2G, 3G, or no connections at all. In rural areas, there are still some areas, or at highway when you are traveling in India, you may get disconnected from the network, right? There is no 2G or 3G data available on highways or in some rural areas. So what we should do for slow connections? First of all, you have to use WebP images. You have to take care of this point, that images are the most dominant format of data after text. And if you talk about the payload, images are the number one data that you consume in your apps. And after that, there are videos, and then there are other rich data. Images consume too much network because they are very heavy. PNG and JPEG images are the most prevalent formats of images that we use in Android or in web. But recently, Google has developed one more format of images, that is WebP. So WebP images are very efficient, they are very lightweight, and for the same quality, they can they are very less in size in comparison to PNG and JPEG. For example, you can also use WebP images in your Android app in your drawable folder. And if you have existing PNG images, you can convert them into WebP images. And let me show you, give you an insight into by how much factor WebP images can be reduced to in comparison to PNG and JPEG images. There is one option to convert existing PNG image into WebP. If I press this, it will show me a preview of the comparison. At the right hand side, you are seeing the same image in PNG format. This is 554 KB, and at the left hand side, left hand side there is PNG, and at right hand side there is WebP image. You can see the comparison. This WebP image is only 15 by 2 KB, 15.2 KB, and this PNG image is 554 KB. And the quality of this WebP image is 75%. You can increase or decrease the quality, but even if you increase the quality by up to 90 to 98%, it is only 18% of the original size. So you can see how much WebP image is going to reduce the memory consumption. And if you are using WebP images over network, that means less network bandwidth is going to be used by WebP images. So first of all, you have to use WebP images in your network request. Ask your server side guys to deliver only WebP images to you. Next thing is, get only the required size of images from the network. This is the challenge that the Android developers have to face a lot of time, because most of the times server side people are not ready to give smaller size images, but you have to be adamant about that. You have to get images only in the required size. For example, if in your Android app you are showing a list of products, and in the list of products you are showing image in every row, and this image is only 100 by 100, you are not going to get this image from the server in the size of 1000 by 1000 or any other size. You have to get this image only in 100 by 100 or maximum 200 by 200, right? If you have to ask your server side guys to give you only the required size of images, because at the server side image processing is very low cost affair. They can do it can implement this thing in an effort of a couple of hours only, right? And it will reduce your efforts, your memory consumption and your network bandwidth to multiple times. For slower connections, you also should consider Glide or Picasso image rendering library if you are not using that any of these. There is also Volley, but prefer Glide or Picasso these days. And I think most of the developers already using that, because Glide and Picasso do not only result in efficient network usage, they have other advantages also. They fetch images automatically given only the URL. They use caching to store fetched images. They show placeholders until the image is fetched, and they also avoid deduplication of request. So they use they have a lot of advantages, and most of the developers are already using these image rendering libraries. And also, if you know that your users are going to use your applications in, you know, in the areas where there is less network or in unpredictable network environment, you can use multiple APIs to detect the network quality and take the decisions on the basis of that. For example, if you are going to download a heavy file in your application, first you would like to know whether the user is on Wi-Fi or 3G, because you are not going to download a heavy file on 3G data, because 3G or 4G data, these are metered data. That means users have to pay a cost um, for this data, and especially in countries like India, the cost of data is very high in comparison to other developed countries. Right? So you can use these APIs like connectivity manager dot is active network metered. It will return you whether the data whether the data is metered or not. Connectivity manager dot get active network info, it will just return you the info of the current network the user is connected to, whether it is Wi-Fi or whether it is 3G or 4G, and whether the user is connected to the network at all or not. And the third is get network capabilities. It will return you the all the capabilities of network, like whether it is 4G or LTE or Wi-Fi, or what features are there in this network, what are the capabilities of network, and so on. So you can use these APIs to predict the network environment in your user's device and take the decisions on the basis of that. Make app usable offline. This is very important. You should download data for offline use and store the data in either shared preferences or in content provider or in database. And you can use that data to show the relevant information to the user when the user is offline for a continuous time. Sorry. Or when the user has just or when the data network is intermittent, and user is switching from online to offline or offline to online very frequently. We have already talked about this, you should batch the network request to be fired up later. For example, if the user is offline for some time and user is doing some operations, you should not very frequently show the message to the user that you are offline. It will just irritate the user. Instead, just consume that action and batch that network request for a later time. For example, your user has when you use WhatsApp, and when you type a message and send this message, the WhatsApp app doesn't show you that you cannot send this message. It doesn't show you that you are offline and you cannot send the message. Instead, it just shows you an icon indicating that this message is not sent right now because you are offline. And it will automatically send the data, that message, when you go online again. So you should adopt the same type of strategy in your application also. Next thing is, and last thing is, bandwidth. You should take care of bandwidth. You should detect the bandwidth in your in your device, and you should act upon that. You should prioritize bandwidth. You should prioritize your network request. You should you fire on the important network request first, and then the secondary request later. Detect network changes. You should apply a listener to detect the network changes, whether it is going from offline or online or vice versa, and act according to that. Take care of offline situations. We have already talked about that. Prepare app for worst network conditions. Yes, you should not assume that the network in your user's device will always be good. You should design your app taking into account, assuming that your users are going into worst network conditions, in offline situations, in intermittent network connectivity, and so on. And you should design your app according to that. And lastly, in Android Studio, you have network monitor. Using this network monitor, you can see what network requests are consuming how much data. And if you see frequent spikes and a very high spikes, or if you see an abnormal behavior in this network monitor, you can act on that, and accordingly you can uh, adapt any of these strategies we have discussed so far, and you can optimize the network consumption in your app. Thank you so much. And at last, there are some references that you can follow. Building for Billions, just search about it in Android. Building for Billions on net or YouTube. It will give you a lot of resources about network usage, battery consumption, and other things. Android performance patterns, search about this on YouTube. You will have a lot of videos to watch. And lastly is the Colt McCann's. This is a Google developer who talks a lot about network and battery optimization. You can see his talks on YouTube, and you can take benefit from that.